This lesson is going to be on sum and difference identities, and I'm fixing to uncover these identities. These are not ones that you'll have to have memorized for the test, but you do need to write them down in your notes because you'll end up using them on all of the problems. Okay, so this is what you need to copy into your notes. So you have addition and subtraction for each trig function. So like if they talk about the sum identity for sine, you know, this would be the difference identity for cosine and so on. So you'll need to copy these down. Alright, so using these identities, we're going to find the exact value for sine of 75 degrees. And so that's not one of your familiar angles. You know, if I ask you for the exact value of sine 30 degrees, you're supposed to know that. You know, it's 1/2, but 75 is not one of those we know. But we can use the 30 degrees, 45 degrees, and 60 degrees to help us out here. And then, of course, also use the identities to help us. Alright, so between 30, 45, and 60, what two of those numbers can you add or subtract to give you 75? And for this particular problem, that would be sine of 30 degrees plus 45 degrees. Now, since that's addition, it doesn't matter which of the two angles you write down first. You'll still end up getting the same result. Now, in the identities that I had you to copy, it referred to an angle A and an angle B. So for this problem, this is going to be your angle A, and this is going to be your angle B. Okay, so let me pull the identities back up here. So what we have is we have sine, we have addition, so this is going to be the identity that we're going to follow. So you're going to copy this part down exactly as it is, except you'll put 30 degrees in for each of the A's, and then you'll put 45 degrees in for each of the B's. Okay, so that's going to end up giving us sine 30 degrees times cosine 45 degrees plus cosine 30 degrees times sine 45 degrees. Okay, now refer to your table of values, your exact values, and substitute those in. So sine 30 degrees we know is 1/2. Cosine 45 degrees, again, you got two different values there, the one that's rationalized and one that's not, so that's your choice. I'm going to use square root 2 over 2. Plus, okay, cosine 30 degrees is going to be square root 3 over 2. And then again, you have sine 45 degrees, which has, again, the two different forms, but whichever form you used here, definitely stick with the same form on this one. Don't switch it up, or that'll kind of complicate the simplifying. All right, we got multiplication and we got addition. So just order of operations, multiply first. So multiplying these two fractions, we would have square root 2 over 4. And then multiplying these two, we would have square root 6 over 4. And it's already set up for you there with a common denominator. Now we can't physically add square root 2 and square root 6. If you remember, when you're adding radicals, the number underneath has to be the same to actually combine them together. So this is going to be your answer. This is your exact value. Now if you wanted to check it, just go to your calculator, of course in degree mode, type in sine 75 degrees, and then type in the result you have here, and those two decimal approximations would be the same. So that would be an easy way to check it. Okay, next one. We're going to take tangent of 7 pi over 12. Now the first thing that you might want to do here would be to change the 7 pi over 12 to degrees, just so you can figure it out a little bit easier. But 7 pi over 12 is equivalent to 105 degrees. Okay, so for the 105 degrees, that's going to be 60 degrees plus 45, and again, since this one happens to be addition, you could use 45 plus 60. So this time we're going to use our tangent identity. Of course, it would be the addition one. So this will be the one that we're going to end up following this time. So again, the way I have it written, my A, well, let me rewrite it here. I have tangent. Now, I've got it in degrees over here, but since this is in radians, then let's write it here in radians. So the 60 degrees would be pi over 3. Plus, and of course, 45 degrees is pi over 4. Okay, so this is going to be the A, and this is going to be the B whenever we substitute it into the formula. So I would have tangent of pi over 3 plus tangent of pi over 4 divided by 1 minus tangent of pi over 3 times tangent of pi over 4. Okay, so go through and replace those values. Of course, these are, 60 degrees, 45 degrees, so replace everything with those exact values. So tangent 60 degrees is square root 3. Tangent of 45 degrees is just 1. And then 1 minus, again, tangent of pi over 3 is square root 3. And you're going to multiply that times tangent of pi over 4, which is just 1. Now, you would need to do the multiplication. Of course, the square root 3 times 1 is just going to be the square root 3. And there's not any further simplification that you would have to do to this one. So again, you could check this one the same way. If you're going to check this one, though, you would need to have your calculator in radian mode because of the 7 pi over 12. And then, of course, the decimal approximation here should be the same as what you have here. Okay, next, still using, of course, the identities, but just kind of in reverse order. All right, so this time you're asked to write an expression as a single trig function. So, of course, single means getting it down to where you have only one trig function, like in this case here I've got 4. Just look at your identities and see which one this looks like. Like the pattern that I see here is a cosine, cosine plus sine, sine. So if I pull up my identities and I'm looking for cosine, cosine plus sine, sine, that's this one. Cosine, cosine plus sine, sine. So this is going to be the difference identity for cosine. All right, so that would mean this is the A and this is the B. So of course over here this is A and this is B. So working backward, you have cosine of A minus B. So that would have to be 3x minus 2x. And that would simplify just to be cosine x. So there's your answer on that one. Okay, one more like this one. So again, looking at the pattern that we have here, we have sine, cosine plus, and then cosine, sine. All right, so sine, cosine plus, it looks like this one, sine, cosine plus cosine, sine. So this is going to be the sum identity for sine. Okay, so since that's the one we're using, this is the A and this is the B. So again, this is the A, this is the B. So working backward, again, we figured out that it has to be the sum identity, A plus B, so that would have to be 15 degrees plus 75 degrees. So that's going to end up giving us sine of 90 degrees if you add those together. Now this time, since I have an exact angle, like a while ago I just ended up with X, this is one of those that you are supposed to know from your table of values. Of course, now that we've done some of the graphing, you might even figure out what this is based on your graph, but sine 90 degrees is just a value of 1. So that one you'd be able to go just another step further.